Hello. In this slide deck, we'll be talking about the requirements engineering process. So here we have Dilbert, who is here to inspire us once again. His customer says, the project requirements are forming in my mind. Now they're changing. Wait, okay. No, wait, changing. Oh, done. Naturally, I won't be sharing any of these thoughts with the engineering. And Dilbert replies, I've budgeted for some goons to beat it out of you. And this is kind of the way I like to think about requirements engineering, is that we have to kind of intellectually beat the requirements out of the customer. We've got to understand what it is we're trying to get, and then we've got to convince the customer. We've got to tease those requirements out of the customer. And often it's not that they're holding them back, like our helpful customer here, but that they don't know what's to be delivered. They don't really understand what the product can do. And this isn't a statement about the customer not knowing really what's going on. It's a statement that we will all understand better what is possible by seeing what the software can do. And this is a big tenet of what we can do with like agile development. So we're going to start off by looking at how are requirements stated for the customer or for the developer. And we'll see how that kind of plays into this and gives us a bit of a framework to move forward. And then what is the difference between a functional and a non-functional requirement? Let's see what those are. So first, let's talk about how things are phrased. If we're talking about requirements engineering, this is the process of establishing the services that the customer requires from the system. So the services that the customer requires from a system. These services are just usually the features. If you're talking about a word processor, we require the ability to open a document, save, print, that kind of thing. And it is the constraints under which it operates and is developed. So requirements engineering is also establishing the constraints under which it operates and is developed. And what do we mean by that? Well, constraints under operation could simply be the amount of hard drive space or processor usage we've got. And is developed is interesting because we can specify requirements on the development process. For example, if you're developing something top secret, you might say that all developers must have a certain, level 3 security clearance. Or if you're doing it in-house, or you've contracted externally, but then the software is going to be given to your in-house team, you might say that all software must be developed in TypeScript or something like that. So if we go to phrase our requirements, we can talk about it being for the user or kind of more for the developer. And we'll see how we phrase that. So we talk about a user requirement. So a user requirement is a high-level description of what the customer needs the system to do. This is a qualitative analysis or qualitative description of what the customer needs the system to do. These are the kind of things that when you ask somebody about what do you need from your car or what do you need from a piece of software, it's the kind of things they'll tell you. I need it to be able to open a PDF. I need to be able to write changes into the PDF. So we'll be using English statements and diagrams to try and convey that information that the customer has given us. And this may be the basis of bidding on a project, for example. The system requirements, so not a user requirement, but a system requirement, this is more like the functional specification. We're documenting precisely what should be implemented quantitatively. So this was a document detailing precisely what should be implemented quantitatively. So when you said, for example, you want to be able to write on a PDF, do you want to be able to edit the text with your keyboard and like change the actual text in there? Or do you want it to kind of be over top, almost like the person's going with a pen over top? Do you want to support just the keyboard, or do you want like a mouse input? These kind of things. So this is often more formal and technical than the user requirements. The user requirements are from the point of view of what your user is thinking. And then when the developer gets in there and starts thinking about the details of things, that's when we start to transition into the system requirements. The use of these is not only for the developers to understand, okay, this is precisely what we want it to be done, but also it's good for maybe if you're negotiating a contract, if you're in more of a plan-driven approach, or you're trying to give a fixed bid on something. Let's look at an example. So if we're talking about a healthcare management system, we're talking maybe patient management. So if you go into the local hospital and then they'll say, okay, what's your ID numbers and so forth, and it'll pull you up and give you some information. That system will have information on all the patients, the drugs, and so on. So here's a user level requirement. The medical healthcare patient management system shall generate monthly management reports showing the cost of drugs prescribed by each clinic during that month. Okay, we want to know for each clinic how much the drug costs. That sounds pretty good. Now, that's great from a kind of a high level point of view. But then if a programmer gets involved and say, wait, hang on, what about the details here? When is it done? How big is it? What goes into it? So here are some system requirements that we might get from that. On the last working day of each month, a summary of the drugs prescribed and their costs and the prescribing clinics shall be generated. The system shall automatically generate the report for printing after 5:30 p.m. on the last working day of the month. A report shall be created for each clinic and shall list the individual drug names, the total number of prescriptions, and the number of doses prescribed, and the total cost of the prescribed drugs. And so forth. We get into all these details. With these details, we can start to look at, like, for example, item 1.2, I'm thinking, wait, we're generating a report for the month, but we're generating it during the month, at the end of the last day of the month. If the place is closed, that's okay. But if there's a chance they could still be open, then more drugs might be prescribed. And all of a sudden we can start to think about 1.2 and say, hey, let's actually do it on the first day of the next month. And that kind of idea. So here's an exercise. I'll leave it for you to do, and we'll do it right now actually. So we're going to classify each requirement for a slide presentation software, such as the one I'm using here to show slides, like PowerPoint, even though this is not. We're going to classify it as either a user requirement or a system requirement. So I want you to pause the video now and go through for each of these 5 and annotate if it's a user requirement or a system requirement. You paused it, right? You done? Good. Okay, so the first one. As a user drags a slide while reordering a slide deck, other slides move out of the way with an animation effect lasting a quarter of a second. Well, that's very specific. It's not just saying an animation. It says they move out of the way, and we got a quarter of a second in there. So I'm going to say that's a system requirement. The system supports reordering slides from a thumbnail view via drag and drop. That sounds more like a user requirement. That's a high level. If we contrast the first two, they kind of go together. One's more user, one's more system. A user may animate content onto a slide where it is initially hidden and then appears. That's being very specific about what we mean when we animate content onto a slide, but it doesn't have all the details. So that would be a user requirement. We're going to animations for the current slide are displayed in a tree view. Well, the tree view is something very programmer-like. And so I'd say, well, the tree view there makes me think it's a system requirement. Unless my user was really up on the different ways of showing content, in which case maybe we'd talk about a user view. If you wanted to make it more specific, maybe it's a tree view showing an icon, the name of the thing that's being animated, and the animation effect. In which case, that would definitely be a system requirement. Animations may be reordered by clicking and holding the up or down arrows to move an animation up or down the animation order. This moves at one position every half a second. Okay, we're talking about specifically what we can do with this button. We're talking about the rate it happens. That feels very much like a system requirement. And these would be kind of a great kind of idea about make a judgment call on a requirement. So let's talk about functional versus non-functional. So a functional requirement is what the software should provide. A functional requirement is what functions the software should provide. So an example would be how the software should react to a particular input or in a particular situation. And again, this is the kind of thing that we often are kind of stipulating. We're saying, okay, this is what the software must do. A non-functional requirement is a constraint on the software, such as timing or the development process, or maybe standards compliance. These often apply to the whole system rather than an individual feature. And I really like this point. They often apply to the whole system rather than an individual feature. And this is useful when we're trying to categorize a requirement as either functional or non-functional. If you can point to a line of code or a class and say, this class implements that. So for example, the animation effect you get when you drag and drop a slide, that you can point to the line of code of the class in the code and say, this is what governs that animation. So that would be a functional requirement. Something that would be a non-functional requirement would be something like the performance of the system. If you've got a system that has poor performance, you can't just write a little extra code to make it high performance. It's likely something across the whole system. Likewise with security or with reliability. You can't say, well, this system's unreliable. All we need to do is write one extra little bit of code that makes it reliable. It doesn't work that way. So that's an example of a non-functional requirement where it applies to the whole system. So by thinking about these functional requirements, we can talk about a functional user requirement. This is a high-level statement of what the software should do. So it's functional and it's user. That's those two ideas put together that we've talked about now. User meaning high level, functional meaning a statement of what it should do, very concrete. A functional system requirement is going to be the details. So we'll describe the software services in detail. So we're talking about an individual feature that can be pointed to in one area of code, and we're going to talk about the details of that. Now, of course, problems will arise when requirements are not precisely stated. There's a lot of ambiguity that's possible as you interpret different things. And a lot of great jokes are built on this. So for example, there's a classic joke is, one morning I shot an elephant in my pajamas. I'm not sure how he got into my pajamas. Ba-dum-ching. The classic joke. Of course, they're talking shooting here with a camera, not anything else, I hope. Next one. Kids make nutritious snacks. Is that they're creating their own snacks or that Dracula has, oh, never mind. And next one, I love this one. Police help dog bite victim. Did the police help the dog as it was trying to bite the victim, or did the police help the person who had been bitten by the dog? So we can talk about some imprecision in requirements here. We can have a functional requirement for the medical health patient management system. A user shall be able to search the appointment list for all clinics. Each staff member shall be uniquely identified by his or her 8-digit employee number. So, consider the term search. Maybe the user's intention was that we were able to search for a patient across all of the clinics. Right? We want to just one search, do it all. Maybe the developer interpreted this as we're going to search for a patient in any one specific clinic. So go ahead, pick a clinic, and then search for it. I was trying to book an appointment recently, and I said, okay, I was thinking I wanted to book an appointment at a particular time, and first I had to select which of the people I wanted to book an appointment with. Well, I didn't care who I booked it with. I simply wanted the time, and the system was forcing me one way versus the other. So sometimes it matters one way, sometimes another. We have to kind of spell that out quite clearly. You can imagine for the second one, the 8-digit employee number. Some things there would be like, are there any dashes or hyphens or commas? Is there any encoded meaning inside of it, like the first 2 digits, the year you were hired? Can the first digit be a 0 or not? Can we put in characters like E's and X's in the middle? If we think about requirements, we really would love them to be complete and consistent. So in principle, we want both. Complete means that it describes all of the required functionality. Describes all required functionality. If you talk to the customer and they give you a complete specification, then everything that they wanted, they told you. They told you about every single feature. And of course, consistent is that there are no conflicts or contradictions in the requirements. Wouldn't that be nice if there's no conflicts or contradictions in the requirements? We can't always get this. This is sort of, I would say, practically impossible. If you ask Gödel on his incompleteness theorem, he'll tell you why. But to produce this, because if you are specifying everything in detail, a complete description of everything the customer wants, it's likely that they'll say things that don't simply work together. And it may be things they don't realize. So for example, they want the system to be easily extended by third-party developers. They want it to be very performant and very, very speedy to use. They want it to run on all types of hardware, and they want to be able to easily move their data from one system to another, while also maintaining really high system security. Well, system security, easy access, portability, and performance don't all go together. You can't have it all together, unless, of course, it's very expensive and running on incredibly high-end hardware, which we don't want. So there we have a contradiction or a conflict. So that was functional requirements. Things like, I want to be able to click on the print button. I want to reorder slides. Those are functional requirements. If we switch over now to talk about non-functional requirements, first off, it feels like this means, are you describing what's going to happen when it doesn't work? When my Xbox catches fire, no, that is not a non-functional requirement. That is a non-functional product. So a non-functional requirement defines system-level properties and constraints. So non-functional, again, is something that applies to the whole system. A non-functional requirement is talking about defining system-level properties and constraints. Things like reliability. Reliability is the whole code, it gives you reliability. Response time, if you have one part of your code that's slow or a bunch of parts of your code that are slow, it drags down the whole system. And storage space, how much space does the whole system use? Does it fit on a single DVD, for example? We can also bring in a dimension about development process constraints. Development process constraints. Perhaps development programming language, or a development method that they need to use in order to apply for certification on an airplane or something like that. So the non-functional requirements may be more critical than functional requirements. Well, how would that be? A non-functional requirement is something like security. Why would that be more important than a functional requirement like can save or print? Well, in a lot of cases, if they're not met, the system is simply useless. It can't go into production. Think about courses. We've got a lot of features we'd love courses to have, but if courses was not secure, we simply couldn't even run it. It would be a non-starter. If people could easily hack it, we simply could not use courses to store student grades. So that is perhaps one of the most critical requirements for courses. And the fact that you can actually submit assignments to it is nice. That's a core feature. But if it didn't do assignment submissions, we could still possibly use it for something else. So a non-functional requirement can be more important than everything else. Now, in order to kind of inspire you as to what you might be thinking about for non-functional requirements, we can kind of start breaking this down a little bit into some ideas. We could talk about sort of security. Where is security on here? Organization, product requirements, dependability, security requirements. Here it is. The ability not to be hacked. That's a big one today. All systems pretty much need to have some level of security. Depending on how high value of a target you are, you need to up your game on that. We can talk about efficiency, and that can be sort of maybe space efficiency. If you're releasing a game that's got to ship on a DVD, well, you've got a limit of whatever the DVD or the Blu-ray can actually store. Anything beyond that, you've got to find a new way to make that work. We can always go over here also to external requirements, maybe ethical requirements. If you're talking about, there's a whole bunch of conversations around what Google was doing with their AI systems and the contracts they were accepting. They brought in some ethical requirements that the company was sort of going to impose. And so an ethical requirement on that. A regulatory requirement might be something along the lines of, if you want to get it certified for avionics in an airplane, you might need to be able to point to every change you've made and trace it back with traceability back to why you made that change. Or for each line of code in the product, explain what requirement that traces back to. So these non-functional requirements, as I said, may affect the overall system. They may affect the overall system architecture. So we're not just talking about a single class. And you can't say, well, you go and implement this security for the whole system. A good architecture will let you do that and kind of isolate some parts of your security model. but they may dictate overall system architectures. So if you wanted to, for example, have a very performant system that is high performance and very responsive, you can't have a huge number of layers. Each layer in the software does its own validation and transmission between the layers. If you have a huge number of layers, you've got quite a few steps to go through. So if you want to increase performance, maybe you have to shrink the number of layers. Or maybe you have to change your database architecture and the way the database works, or it has to be moving to the cloud. All of these sorts of things can have deep implications. So we do need to think about these non-functional requirements early on. You can't, for example, take a poorly built building and then improve it easily to make it, high reliability or high structural strength. A little bit similar with software. You can refactor software quite easily, but if it's got a poor architecture, poor kind of code quality going in, you can't just refactor it to make it reliable very easily. So a non-functional requirement may impose a number of functional requirements. So above I said it may change the architecture. Here it may change a whole bunch of extra requirements, and those might become functional requirements. So maybe you're talking security. We want a high security system. Okay, that would be a user level non-functional requirement. We want high security. We'll explain what you mean by high security. Okay, we want a system that is not found to have, not having a certain number of bugs when using the following 3 penetration attack vectors and so forth. And we can maybe describe that with some standards. So that would be a non-functional system requirement where we're talking about the details of it. But then in order to do that, maybe we start to bring in a bunch of functional requirements. And so here, for example, we're talking security. So maybe we bring in the idea that passwords that are stored in the system will be salted and hashed, meaning that we're not storing them in plain text. We're kind of encrypting them effectively. So that is a functional requirement. You could point to the lines of code that salt and hash a password before storing it to disk. So that would be a functional requirement in response to a non-functional requirement. Likewise, you could say, well, we're going to use SSH encryption. We're going to use the following encryption technologies. That, again, is a specific functional requirement, maybe necessitated by a non-functional requirement. Okay, so let's write a non-functional requirement quantitatively. So here's the user's goal. The user's goal is the system should be easy to use and organized such that user errors are minimized. So this is a non-functional requirement because it affects the entire overall, in this case, maybe the user interface. Easy to use. You can't point to one line of code and say, this line of code, this makes it easy to use. And the rest is all just there to back that up. So that's a user level goal. Let's talk about a verifiable requirement. We want to get this down into like a system level requirement. We could say something like, after 4 hours of training, an average user's error rate shall be less than 2 errors per hour. Now, maybe we need to define what an average user is. If you're talking, say, to be used by nurses, maybe you could say, okay, we're going to take, sample 5 of the nurses that are on shift at this hospital in this unit, and they're the ones who are going to use it. But that's the idea, that we're quantifying it. And it becomes something you can go to the customer and say, look, we said we would do this. Here is what we actually specifically stated. We're going to train them and so forth. We trained them for 4 hours, and here they are using it. And look, they used had 1 or 2 errors per hour. Conversely, the customer can come back to you and say, look, we gave the training, and we had 10 errors per hour. Your system is not easy to use. So when you're talking non-functional requirements, sometimes it's a bit nebulous as to what you're talking about. For functional requirements, we can all point to features we like. If you talk about a game that you've got, you can talk about the features. Oh, I love that I can aim this, or I love that I can see the following. But what do we mean when we talk about non-functional? So one big area would be speed. We can talk about transactions per second. For example, if you're dealing a web system or an accounting system. We can talk about user response time. So every time the user clicks a button, how fast does it get back? And for a game, the obvious one we all love is screen refresh rate. And perhaps screen refresh rate on a given piece of hardware. For ease of use, we talked about it a minute ago with training, so maybe training time, or training time with errors per minute, or hour. For reliability, two big ones are mean time between failure, often called MTBF, the mean time between failures, and the rate of failure occurrence. How often does a failure occur? So that'll be the reliability of our system. Robustness is kind of contrasted to reliability. Robustness would be the time it takes to restart after a failure, or the probability of data corruption on failure. So you can have a robust system that fails often, but it comes back online quickly and doesn't corrupt its data. So it's robust, but not reliable. Or you can have a reliable system that's not robust. It only crashes once a year, but when it does, it's down for a week and you can't get half your data back. So a quick exercise here, we want to fill in the following grid with examples for a Minesweeper game on the computer. You know, the game where it comes up with a grid and you click on, is this a mine or not? And you mark things as mine and move around the grid. So we want to talk about a user requirement, something high level, or a system requirement, something low level. We want to talk about functional requirements, meaning specific features, or non-functional requirements, meaning just applies to the system as a whole. So I'll give you a chance to do that now, and we'll think about it again probably in person in lecture. So what did you talk about? We talked about requirements. We want to know what do the requirements state, so what the system should do, and any constraints on the system. The functional requirements are the services that we must provide, and the non-functional requirements are the constraints on the development or on the system. We can talk about they might be the emergent properties of like reliability, robustness, and so forth. And in general, they apply to the system as a whole. All right. Thank you very much for watching.